Hello everyone, this is Vince Hamann, your host for the next session in customizing DraftSight via Lisp. If you have not watched the previous videos, I would highly suggest you go back. You could start with session 3. You don't necessarily have to start with 1 and 2, but for those of you that have watched those sessions, welcome back, and we're going to continue on with our Lisp training. So, a couple things, as I looked at the previous recording and started thinking about advantages of Lisp, there was another advantage that I came up with that I didn't mention, and that is that currently when we look at how many CAD users that are out there that have access to CAD applications that can support Lisp, we're talking millions of users. So there's another opportunity, or there's another advantage here, and that is an opportunity within, even just in the career standpoint, in that there are literally tens of thousands of companies that need help either streamlining their workflows, their processes, or converting other old Lisp routines, or looking at those things and helping them to move forward and use them today. Because in many cases, and as you start to learn more and more about Lisp, you're going to find that there are certainly situations where you can really streamline workflow processes, in some cases significantly. So something to think about. Anyway, today, what I'm going to cover in this session is going through more examples of defining functions, list operations, things we can do with Lisp. We talked about Lisp last session, and then we'll dive deeper into strings and the things we can do with strings and those functions, converting values, converting numbers and strings and different types of object types, and then we'll get a little bit into some entity and selection sets as we finish up this session. So to get started, we'll just do a quick review. Last time we spoke about operators, plus, minus, multiplication, mathematical operators. We talked about setting variables using setq for local variables and setvar for drawing variables. We also created lists by using the list function and or the cons function to create what's called a dotted pair list. We also showed a couple different functions on how to show the values, either using print or print C or using an alert. We also did commands. So these are CAD commands, in this case DraftSight commands that we can put into a Lisp function and then run that command. And then how to load your Lisp files or your Lisp applications that you create using Notepad or an editor. And so we also talked about the defun command, define function, define command. We'll talk about this a little bit more in depth. In fact, that's the next thing to really cover. In our previous session, I showed how I create functions for doing fillets. And let me just build the screen out here. We'll talk about the syntax of this. Basically, and I'll show you the full list that I created. It's basically a function, defined function. It's C:, to define the name of that command that we're going to use. You'll see there's an open and a close parenthesis right after that. We'll talk about that as we get into this command a little deeper. And then it's the command that we're going to run. At the end of this, I had a print C, and that really was just to suppress the nil that was coming up at the very end. And so when we looked at the startup that I had created, it looked like this. There were semicolons, we had startup. This is just basically a comment line. In fact, anything that starts with a semicolon in a Lisp file is just a comment line. It doesn't read any of it. And then we see these functions. Now, I did want to show this, and I showed this in an earlier session. The same syntax or the same thing in Notepad++. As you can see, there's some color coding here. Now, this is my color coding that I set up, but as you start doing more with Lisp and you get bigger files and they start to get more and more complex, having this color coding actually really helps a lot. As you can see, if I made a typo in the command, like sometimes if I'm doing something really quick and I hit 3 M's instead of 2, the command would not show up blue, it would actually still be a different color, be yellow, and that would be a really quick indicator that I wasn't typing something correctly, just because of the color coding. So just something to keep in mind. And probably towards the end of these sessions, I will go through probably more in depth on Notepad++ and how to set it up and create an interface that looks something like that as you're creating your programs. But let's talk about the defun command. The first there's two things that we can do with defun, and the first is we can define a command. And this is one of the things I really like about Lisp, is the fact that if I don't have a command that does something, I can just create it and I can define it with the name that I want to define it as. And so, defining this command, in this case C:command, I can make a command to pretty much do anything in the system. So again, we use C: to specify the name that it is a command. Now you'll notice in the previous examples I had an open and closed parenthesis. There has to be an open and closed parenthesis after the defined function command name. Now, if we want to declare local variables, we have that option. You do not, in this case, there's a slash mark that gets put in, and then we define those local variables. You can declare them. You don't have to, but in many cases, it makes sense to do that so that this program doesn't step on other programs. And we'll talk more about that as our programs get more and more complicated here. So the other type of defined function is a Lisp function. And in this case, we can define the function and it can have options. Also, it can have local variables. And then once within those parentheses after the function has been defined, here we can run or put the values for our program. So with the difference between defining a function and defining a command is, notice or remember, the command cannot have options. Now you can if you embed those options inside the program, but in this case, when I launch it, in the way I launch it and the way I type it into the system, there aren't command options that are there as part of the naming convention. Maybe that sounds a little complicated, but as you see this building out, you'll probably get a sense of what I'm talking about. So let's talk about some examples. Now, this one we've seen before, and I've talked about the syntax. Now, we did something last time where we created some layers, and what I'm going to do here is use a function to do that layer command. Because we're doing the layer command over and over again, why not create it as a function and repeat that process? So here's the syntax. I basically say define a function. I'm going to call the function mLayer. And then in that first set of parentheses, I'm going to define two options. The first option is going to be lName, and the second option is going to be lColor. And so when I run my command, like we did previously with the layer command, we're going to do the command -layer make. And in this case, instead of using a hard-coded name or color for these, I'm going to use whatever the value is of lName in this location, C for color, and then whatever the value is for lColor in this location. And then again, because I've already got the name, I can repeat that, use that name, and then hit my enter. So what does that look like? This is the example that I gave you in the last session where we created a whole list of commands and we put all these in here. But instead of doing that, we could create a function called mLayer with these two options. Here's the command sequence. And then to run it in my Lisp routine, in my mLayers command, I can simply say mLayer, name of the layer, and the color. And you see now, instead of having to type all this in terms of making this work for all these layers, I can simply create one function that does this process over and over and over again, and then just takes those pieces of information, the data, and runs with those two pieces. So, how does that work? What does it look like? So if we jump over to DraftSight. All right, so now that I'm here, if we take a look at this drawing, you'll see that I don't have any layers. It's a new drawing. It's a no-name drawing. And I'm going to run that routine, but before I do that, let's just take a quick look at it. In fact, I'm going to bring up Notepad++ here just so you can see how it looks there. And I might do a couple, notice I added a couple more layers in this program, and then let's just do another print C to say, and you'll see this as I do this in many cases, I use a /n for new line, and I'll show you later why I do that. But here we could say, we could just say layers created ... like that. So it puts that at the end of the routine. I'll just save this. I'll come in into DraftSight, we'll say load app, and we'll grab our mLayers function that I just created, and here it says layers created. Now you'll notice when I come down Here are all the layers that I had within that system. So very quick, very easy. It created, you can see it ran through the process of creating all these layers. Now, I'll show you another little trick here. When I normally write routines, I'll often leave all of this command echoing that you see here on the screen so I can verify that it worked. But sometimes we don't want to show that. So I'm going to just show you one more little trick here that I do. And so looking at the program, again, the way this works is when you load this, it loads up, it just starts running this sequentially. So the first thing it's going to do is it loads this defined function program, and then it uses that function as it continues on down through the file. But something I might do here is I might set one of my variables called cmd echo to 0, and I'm gonna command echo. I'm gonna turn that off, and then when I'm done, I'm gonna set it back to 1 and turn it back on. Just a very slight change in how I do this. But what we'll see is now if I come back into, let's say I start a new drawing, and I go to load app, and I grab my make layer program, you'll notice it says layers created here, but when we look at the text screen, you don't see all of that information going by. So oftentimes it's just a little trick that I do. A lot of times for different customers or different users, they don't want to see all these things happening. They just want to see that something gets quickly accomplished. So you can actually suppress all those commands that were just going past on the screen. However, in my development stage, I might turn that on to make sure I can see it in case something doesn't work or blows up. Then I know, did I miss one of the options in the command, or did I miss something? So just a little trick. Thought I'd show you that during this example. So let's talk about lists. I went through a couple different options in lists and how we create them in the last session. But now once we have a list, how do we get the information out of the list? So there are two primary functions that I use. The first one's called car, which when we use car, it basically selects the first item in a list. So if I use the command or the function here to say create a list with the values 1, 2, 3, and then I use the function called car, it takes the first value out of that list. The next function we use is something called CDR, and what that does is it gives you everything except for, it's basically the opposite. It gives you everything except for the first item in the list. Notice when it returns the list, it returns it as a list, where the first one returns the item not as a list but as an individual item. So when we look at lists of items, if I just want to grab the first item, I use car. If I want to pull that first item off and use the rest, we use CDR. Now, I will tell you there is a whole handful of functions that are CAR, CADDR. There's all these different variations of these two commands, but primarily I only use these two. And the reason for that is I've found that some of those others tend to be a little quirky, and I don't know, for whatever reason, I guess I just never took the time to remember or memorize every single one of those and how they work. Instead, I use something called nth. Now, nth, what that does is I can use nth to give me the value from a specific position within a list. So if I just don't want the first item, I want the second or third item, I can use nth to say grab the fifth item in this list. Now, if you'll notice here closely, this isn't a typo. You'll notice if I say take the first position in the list of 1, 2, 3, the result is 2. And why is that? If I take the second position in this list, the result is 3. The reason is because all lists start with the first position as 0. This is a little bit of a quirky thing with Lisp that you might have to understand, but the very first position in a list is position 0. So if I want to grab a different item in a list, I have to understand that the numbering sequence is off by 1. So for instance, let's say I set a variable to list 3 to the list of the numbers 1 through 6. Now, if I say grab the third position in the list, the answer should be, in this case, should be 4, because it's going 0, 1, 2, 3. And if I grab the first item in the list, as you might guess, it will actually be position 2. So something very important to keep in mind. But with that being said, I still prefer using the nth command when I'm working with lists over the CAR and CDR, and I'll show you why. A great example is picking a point. If we pick a point by using the getPoint function, the result will be a list of 3 numbers. They're x, y, and z. And so if I set the variable pt1 to get a point in the system, it'll return that value. If I want the x value, I can simply say car the list pt1 and I will get the value for x. But if I want the value for y, I have to actually take the list, use CDR to get everything but the first element, and then grab the first element of the remaining list to get the second element. Or I could use nth. And so in this case, you'll notice if I use nth to get y, it's the same thing. It's the same way, but you'll notice it's a little bit shorter, it's cleaner, it's probably easier, especially when you start looking at getting the third and fourth and fifth elements within a list. Using car and CDR become a little bit cumbersome or probably a little bit harder to manage. And you find yourself trying to think about how those things are falling into play. And so here's an example. If I look at it, if I have pick point, if I want the x, y, and z, down here just using car and CDR, I actually have to do CDR of point, then a CDR of that, and then a car of that to get the z value, where this just to me is a little bit cleaner and easier to understand. But let's take a look at that. Let's just jump over to DraftSight and let's use a function. Let's set q the value v to, let's just say get point, and we'll say the prompt we're going to say is /n pick point. And so when I do that, wherever I am in the screen, if I pick a point, you'll notice the returning value is that. Now if I want to get the first value, I can say car v, and there it is. There's 8.353. You know, I'm grabbing that x value, or the same thing is nth 0 v, and it gives me the same result. So just different ways we can work with lists, but I would highly recommend using the nth for finding certain positions within a list. And again, there are other options for this that you may be aware of and know of, but in some cases I found them to sometimes work, sometimes not work. And in DraftSight I haven't tested all those variations, but in other CAD programs I find it to be somewhat quirky, and so I've always standardized on using nth. So let's talk about strings. Strings are textual values that we can associate to a variable. So in this case, and I showed this last time, we can set a variable like str1 to either a sentence or to a single word. And then we use this function called stringcat, which concatenates 2 strings or puts 2 strings together. And so we can say if the value of string 1 is this is a test, I could say take the stringcat, the value of string 1, and then add today. Now notice I put a space before the word today, and the result will show me a list or a variable, a string that has the space in today. So I'm just basically putting those two things together. Now what are the other things we can do with strings? The first one is we can force everything to uppercase. For instance, if I take the string str1 and I say string case str1, the result will be this is a test in uppercase. Now it doesn't permanently set it because I didn't set the variable str1. I just returned the value in uppercase. I'll show you a little more about this in a second. Now if I want to force everything to lowercase, I put a T at the end. There's an actual option that is available for str case. If there is a T after the string, it will force everything to be lowercase. Many times I have clients that have certain situations where they need something to be all uppercase, or they want to make sure it's all uppercase in their data, or they don't want the case to be that way. And so we can force these things to happen using this str case function. The other function here called strlen, or string length, as I like to call it, it just returns an integer which tells you how long that string is. So if I do a string length of str1, it comes back with the number of 14. It's 14 characters long. And there's another function called substring that will allow me to take that string starting at a position and then however many characters I want and return that value. So if I say substring str1 start at the 8th character and give me 4, the result would be a space te. If I say just start at the 8th character and then not define how many characters I want, it will take it to the end of the string. It'll give me the remainder of the string. So I don't have to define a length, but if I know I want a specific length, I can do that. And we saw, I don't know if I did not show you this before, but there's a function called getString, just like we have a function called getPoint. We can do a getString, and then I could say enter the name, and it will prompt the user for enter the name, and it'll just return that. Now normally we could do this. We could say let's set Q the username to getString / and enter username. And so therefore it would give us that information. So let's talk about example. Where would we use this? Where do we cut strings apart and do things? Well, a good example of that is if I get the variable drawing name, or it will supply the drawing name to me, but it gives me the entire drawing name with the extension. So what if I want to grab the drawing name of the drawing, but I don't want the .dwg at the end of that? How would we do that? So let's just jump over to DraftSight and let me show you an example. So let's do this. Let's say I'm going to set Q the variable v to get var dwg name. And so if we do that, we'll see that the name of this drawing, as we can tell up here, is noname_18.dwg. So if I want to grab that name and I want to strip out the dwg, I would do something like this. I would say let's set Q, we'll call it dwg name, and then we will take and we'll do a substring of the string v, which is what we created before. We'll start at the first character, and then what I'm going to do is I'm going to say let's take the length of it is going to be the we're going to subtract from the string str length of v. We're going to subtract 4, and then we're going to use that. We're going to basically grab the length of the string, subtract 4 from it, which should pull the end, and then that's how many characters we're going to count to retrieve the drawing name. And so if I hit return, it should return the value no name. In fact, if we do an alert and say alert dwg name, it'll come up with the name without the .dwg extension. So just an example of where I'm going to use string concatenation or substrings, stripping out or removing string information. So in this case, the example that I have up here, I'm using the variable instead of saying v like I did in the drawing when we were in DraftSight. We can call this dwg and m, and then we're going to set the variable drawing name to substring dwg and m, and we're going to use that over here and here. Now we could do it. We can also do it this way. We could say, instead of setting a variable dwg and m to the name of the drawing and then stripping things out and using it, we could just say set Q the variable drawing name to substring get var, and I could do that same get var here instead of using the variable. Either way is correct. Sometimes I prefer to do it this way if I want to use that variable somewhere else. Now that I've got the drawing name with the extension, I might need that, or I might want to use it somewhere. So it depends. My rule of thumb is if I'm going to use that or need that variable in more than 2 places later on, then chances are I will set it as a variable and then use that variable downstream. So when we talk about converting values, I think I mentioned this before. We have integers, we have real numbers, and we have strings. How do we convert between those? Now, the one that you're going to use quite often is if I have a real number and I want to present it in either I want to put it in a database or I want to present it as a value, I have to convert it to a string. And so the function we use for that is called real to string, RTOS. Real to string, easy to remember, real to string. And we first supply the number, the real number. We identify what is the format, the option here is what format are we going to use and what's the precision. So if, as an example, I have a number 345.513, I can say, convert this real number to a string, use a decimal format, and then give me one place decimal. And the result will be a string that looks like this. So if I want architectural, I would say, 345.513 with a 4, and I could specify if it's one place, it's closest half inch, two places, close quarter inch, so on. And so you sort of get the idea in terms of precision. It's how many decimal places are we going with that example. The next example is A to I, which is taking a string and returning an integer. The opposite of that is I to A, which is taking an integer and returning it as a string. So if I say A to I 345 as the string, or whatever the variable is that's a string, it's going to return that integer and vice versa. Now, one of the things I find challenging with Lisp is the fact that I believe that whoever wrote these functions wasn't the same person. There's one more function I want to show you. That's called dist of. And what this function does is it takes a string and converts it to a real number. So it's the exact opposite of RTOS. So if I use dist of and I supply this, the result would be 345.5 as a real number. Now, the reason I said that it doesn't appear to me that the same person wrote these functions is because they're very confusing. I like RTOS, real to string makes sense. I would have made this S to I to S, and I would have made this S to R, but that's not the case. Now, I've gotten used to these over the years. I think if I was starting out today, I might actually create a function called S to I, so I know that string to integer and integer to string is those functions. Now, in fact, there are some other functions, and I'll probably share them with you in later lessons on how to convert other things. For instance, a lot of times when we retrieve data from radiuses, the value that gets returned is not degrees in angles, it's actually radians. And so there isn't a function in Lisp that will automatically convert degrees to radians and radians to degrees. So this is a good example of one of the utilities that I'll share with you on how to do that. And basically you could, like I said, you could create your own functions here and make your own that says S to I. But if you can remember, it's the letter to an integer or an integer to a letter like the letter A. Dist of is a little different than RTOS, but those are the ones that we use quite often when we're doing conversions. So let's talk about entity selection and the drawing variables. Now we did cover this. We did cover getVar and setVar. I think one of the things I wanted to point out with these variables is that in some cases, if you're coming from another CAD system, some of the variables in here are not, in DraftSight, are not the same name or named the same. Maybe I can give you an example of that. Let's just jump back to DraftSight. One that I will show you later and we use often is something called CDate. I believe that's one. So if I type in setVar and I type variable name CDate, it will come back and it'll show me the current date in a numeric real number. And if you notice, it says get DT. So in DraftSight, the actual drawing variable that we use is get DT. So if I really want to do that, I can say getVar get DT, and that's going to give me the date. Now, in other CAD systems, we use a different variable. We say getVar CDate, and if you see, it does the exact same thing. So again, back to an earlier example I gave, depending on if you're only going to run your program in DraftSight, then you can use the getVar variable getDT, or if you want this program to run in other applications, you might have to use getVar CDate. But it'll work. That will work in DraftSight. So something to keep in mind when we start looking at some of these variables. Now, switching over to selection sets, there is a function that allows us to select items, and it's called ssget. It's actually the same as the select command. If we're in DraftSight and I just type in select as a command, it'll let me select objects. Now, I don't have a drawing with objects here, so let's just jump over to another drawing. Here's a drawing that has objects. If I say select, it lets me pick objects, and I hit enter, and that's all it does. It has selected those objects. Now, where I can use that, if I come up with a command like move and I say give me the previous objects, it remembers that selection set. That's the current selection set that exists inside of the drawing. So by using the function ssget, we're able to grab a selection set. That's basically what it does. Now, if I specify ssget with an X in quotes, then it grabs every single item that's available in the drawing. Everything that's physically in the drawing, it will grab that. If I use a W, it'll use a select window. If I use a C, it'll select a crossing. And if I use ssget P, it'll select the previous. So these are different options that we can use to grab selection sets of items. Now, let's say I wanted to grab all the circles in a drawing. I could use this Lisp function here to say, let's set the variable all circs to ssget X, everything that's in the drawing that is a circle. And this is an example of where we use that dotted pair list. We create a list of a dotted pair within a list, and this is the format. So you can just simply, once you understand, I'll show you a couple more examples. Once you understand, this is pretty much the format you need to be able to grab objects from within drawings in large selection sets. Now, let's say we want to select all circles. This is how it works. So let's see how that works. If I'm in the drawing here and I say I'm going to set Q, the value V to, let's do an ssget X. We're going to grab everything, but we're going to do a list, and we're going to say the list, we're going to construct cons 0 circle. Close that, close the list, close the ssget, close the setQ. You always have to count those parentheses, make sure you have enough. And it now says selection set here 3. So now if I go to, let's say I go to move, or I want to use a command to move. If I say command, and we say move, and I just use V as the first option for selecting objects and hit my return, that's all I need to do right there. You'll notice it just grabbed the circles in the drawing. Those are now part of a selection set that's set to the variable V. I can always grab that variable, and it has those objects in it. What if we want to get more specific? Let's say we want to grab all the circles on a certain layer. Well, in this drawing I have a couple circles, and these are on layer 3. So in order to do that, now to save some time, I'm just going to up arrow here. I'm just going to add another cons list. In this case, I'm going to say cons 8, number 3. Close that. And now if I hit enter, and I go back to that same move command, notice it only highlights or grabs the circles that were on the layer 3. So now I can pick my point, and I have those I can move around. So here's the syntax for doing that. We used cons 0 to identify the item type, and 8 to identify the layer. So these are two different, we'll call them filters, that we can use within Lisp to define within a selection set whether or not we want a certain group of items. Now if I do anything with that group, or I manipulate any one of the items in the group, it will probably be no longer part of that selection set, so I may have to re-identify it. But here's just a shortcut way to do things. So if I want to grab all lines on a certain layer, all pieces of text on a certain layer, I want to grab all dimensions and put them on a dimension layer. We can quickly do those types of things in these routines by using this same syntax. And as we get deeper into object and entity data values, I'll start to share with you more and more filters that we can use to identify certain types of things with these objects or with these selection sets. So I would like to present a challenge. I was going to show the results of these, but I thought it would be a good example to give you for the next case. For those of you that want to try a challenge, I have two different challenges here. One would be to grab the current username, get the drawing path and the name of the file, and string them together and create an alert box that gives you that information. Might be kind of useful. The other would be to grab the current date and time. Now I kind of showed it to you, but present it in a way that is month, day, year, or year, month, day, in a format that would fit your, a standard format for you, and then show it up in an alert box. So I'll give you those two examples on the next session, but for now I'll leave that as a challenge to see if you can create either one of those programs. All right, so what did we cover today in this session? We went through some examples of some Lisp routines and how to make them a little bit shorter using a defined function and or defined commands. We went through some of the list operations and how to manipulate lists, also string functions, and then converting values, real numbers, integers, and strings. Also, we looked at a little bit about entity selection and how we can do that, and presented some labs. So next time I'll go through those lab examples that I presented to you and give you some examples on how to create programs to do those things. We'll talk a little more about selection sets and then also specific entity selection and what we can get when we start selecting objects, entities, and grabbing data out of those objects and being able to manipulate that data. Also, I'll introduce some things around conditional. We can do conditionals where we say if a value is worth this, do that, or if there's a whole list of conditions that must apply, and then also repeat loops for doing different things as we start looking at our data. And again, we'll get a little deeper into some of these functions that I presented to you. As we continue to move on, I'll show you more and more options within some of these. But for now, I hope you are enjoying going through the process of learning how to use Lisp in DraftSight. We welcome any feedback that you have. Also, I look forward to sharing the next session with you and continuing your journey down this path. Thanks for your attention. Take care.